In this video, we're going to talk about traversals, but I encourage you to look at the in-class activities for traversals first. Again, you don't need to go through all of them, but just to give you an idea of what we're going to be working with. Okay, so as I mentioned before, we're going to look at traversals of graphs, and in particular, traversals of binary trees. We're first going to define what traversals are. We're going to identify traversals that we actually already know, even though we weren't calling them that. And then we're going to define 3 new traversals on binary trees. So let G be a graph. A traversal of the graph is just an algorithm for visiting or searching the vertices of G. So we've already seen some examples of traversals. Eulerian circuits and trails are traversals. We go to every single vertex and we visit them as we go along our circuit or trail. And we did the same thing for Hamiltonian cycles. And we didn't do Hamiltonian paths, but they're very similar. Hamiltonian path is a path that goes through all the vertices. And these are examples not just of traversals, but traversals that happen to be walks. And I want to emphasize the point that a traversal does not have to be a walk. We don't have to hop from vertex to vertex by edges. All we have to do is make sure that we visit all the vertices. So if we're looking at the traversals of rooted trees, one might question why we care about that. Well, as a common application of that is thinking about the directory structure of a hard drive of a computer, right? So in each computer you have what's called a root directory, and we call it a root directory for a reason, because that's actually the root vertex of a tree that has a rooted tree structure. So if you think about how the files and directories are organized in this, they have a rooted tree structure. And so if you can find a traversal of rooted trees, that will allow you to efficiently search through all directories and files, which is a useful thing to have. So we're not going to look at rooted trees in general. That is a pretty hard problem. We're going to stick to just binary trees. And since binary trees are defined recursively, that means we can define our traversals recursively as well. So in general, we're going to have 3 tasks that we're going to do in an algorithm for finding a traversal of binary trees, and we're going to do these in different order. And in general, we can do them in any order that we want. We can visit the root of a rooted subtree of the graph that we're on. We can apply the traversal algorithm to the left rooted tree of the vertex where we are at. Or we can apply the traversal algorithm that we're going to use to the right rooted tree of the vertex where we're at. And we're going to apply these to this particular example. This is a binary tree. And one of the things that is going to be helpful is whenever we're looking at a rooted subtree of this graph, what we'll do is identify it by its root. So for instance, if we want to look at the rooted subtree with vertices E, B, F, G, and H, and that's this one right here, what we're going to say is that is the subtree B. So we're going to identify that entire subtree by the vertex B, which is its root. And we can do that with all the subtrees in that graph. So we're going to have B is going to represent 2 things. It's going to represent the vertex B, right? But it's also going to represent the subtree B that's given by B and all the vertices that are descendants of B. All right, so we're going to start off by describing what a pre-order traversal is. That's the one that is kind of the most natural one to look at. Our first priority is to visit the root. Now, if we can't visit the root at the subtree that we're at, what we're going to do is we're going to apply this algorithm to the left-rooted subtree. And if we can't do that, then our last resort is to traverse the right-rooted subtree. So here's what it's going to look like on our example graph. So we're going to start up at the root, which is A. And our first priority is to visit the root, so we're going to go ahead and visit A. And I'm going to denote all the visited vertices. I'm going to turn them blue. So once I turn them blue, that means we visited them. So now we're on A still. but there's nothing left to visit because we've already visited A. Our second priority is to traverse the left-rooted subtree, so we're going to move left to the subtree B. So we're going to go to B, that's our root. Our first priority is to visit the root, which we're going to do. We're going to visit B. And now that we've done that, we can't visit the root anymore, so that means we got to move left again. So we move left again to E. To E, we're going to go ahead and visit E. That's our first priority. And now we go back up to B because we've already finished off E. So at B, there's nothing left to visit because I've already visited B. I've already traversed the left subtree. That's where the E was. So that means now we traverse the right subtree, and that is going to be subtree F. Well, now that we're on F, we're going to go to it. We're going to visit it. And then, okay, so remember we're on F. We just visited F. Now we're going to, we already visited, so now we have nothing to visit. So that means we have to move left to the subtree G. We can't, we're going to go to G. We're going to visit G. And now we've finished off subtree G. We're going to go back up to F. We've already visited F. We've already traversed the left subtree. Now we get to traverse the right subtree. That is subtree H. And so we go to H and we visit H. So now we visited everything in the subtree that is left of A. So now we're going to go all the way back to the top at A. We've already visited A, so we can't visit it again. We've already visited the left subtree of A. Now we go to the right subtree of A. That is C. And we go to C, and we visit C, and we keep on going. Now we're going to continue, and here's how we've visited them at this point. We visited A first, then B, then E, then F, then G, then H, then C. And now if we apply this to subtree C, we're going to visit D next, and then visit J at the end. See if you can figure out how we do that. All right, so that's our first one, our pre-order traversal. All right, so for an in-order traversal, we just take those exact same priorities, except we change up the order of that list. So the first thing we're going to do, and this is a little bit counterintuitive, we're going to be on the root of a subtree, but we're not going to visit that root. We're instead going to first go to the left if that's possible. And only if it's not possible to go to the left anymore will we visit the root. And then once we visited the root, if we can't go to the left, if we can't visit the root, then we'll go to the right. All right, well, let's see how this works on the tree that we worked on before. So we're going to start at subtree at the tree A, but we're not going to visit A. We're going to keep moving to the left the most we can. So we're going to move to the left to get to B, right? And then we're at B. We're going to move to the left again to go to E. Now that we're at E, we can't go to the left anymore, which means that we're forced to visit E. And now we go back up to B, where we have already traversed the left subtree. And now, since we've traversed the left subtree, now we can visit the root. So now we're still at B. We've already traversed the left subtree, so we can't do that. We've already visited the root, so we can't do that. So now we go to the right subtree, which is F. And so we're going to go to F. All right, so remember, we've just been to F. We just got to F. We're not going to visit F, even though we just got there. Instead, we're going to go to the left, because that's our first priority, down to G. We're going to go to G. We can't go left for G, so we're going to visit G. That means, and then we're done with the tree G. Now we go back up to F. We visited the left, so we can't do that. So now we get to visit the root, which is F. So now at that point, we've already traversed the left subtree. We've already visited the root. And so now we can go to the right, where we go down, and we go to H. So at H, there's no left subtree, and so we can visit H. Now at this point, now we go way back up to A. We've already traversed the left subtree, and so now we're finally allowed to visit the root A. So we're visiting A. And now that we've traversed the left subtree, we've visited the root, now we can go to the right. So we've traversed the left, we can't go to the root, we've already done it, we go to the right, that's going to C. There's no left tree of C, so we can visit that one immediately. And then we just keep on going as we have been. So let's see. So we've done E, B, G, F, H, A, C. The next one we're going to visit is actually J. And then after that, we're going to visit D. So see if you can figure out why we did J first and then did D. All right, so our final traversal algorithm is called the post-order traversal. And that is the least intuitive one because we're going to put visiting at the last of our priorities. So our first priority is to traverse the left subtree. Then we're going to traverse the right subtree if we can't do that one. And only if we have no subtrees to traverse on the left or the right do we get to visit the root. All right, so here's our tree again. So we're going to keep going left until we can't go left anymore, all the way down to E. At that point, we can't go left, can't go right, so we get to visit our vertex E. So that's fine. So now we go back up to the subtree B. We've traversed the left. We're not going to visit yet. So we can't go left. We can't visit yet. That's our third priority. We're going to go right to F. And then once we're at F, we're going to go left again to G because that's our first priority. And at G, we can't go left or right, so we're going to visit G. Now we're going to go back up to F. We've traversed the left. Now we get to traverse the right because we're not going to visit until we can't traverse anything. We're going to go right to H, but at H, we're forced to visit H. And only now do we get to visit F because we can't go to the left or right, so we visit F. Now we go back up to subtree B. Whoops, we go back up to subtree B, as I mentioned before. Can't go to the left, can't go to the right because I've already done that. Finally get to visit vertex B. And now we kick ourselves back up to A. We've already visited on the left, but we don't get to visit A left yet. We got to go to the right. So we go to right to C. To C, we check on the left. We can't go there, but we can go to the right. At D, we can go to the left. We go down to J, and only then do we visit J. And then we keep on continuing. The ones we've already done so far are E, G, H, F, B, and J. The next one we're going to do is D, then C, and only at the very end do we visit our original root A. All right, so that should give you an idea about how these traversals work. Go ahead and work on those on the in-class activities called traversals included with this video.